Hello dear students. Today we are going to discuss about the topic of chemistry, the unit second electrochemistry. So electrochemistry, the chemistry is having various branches. In the same way, electrochemistry is the one of branch of chemistry in which the transformation of chemical energy into electrical energy and electrical energy into chemical energy can be studied. So basically chemical energy and electrical energy, two transformations are studied in the electrochemistry, right? Now chemical energy will transform into the electrical energy to have the current, to have the electricity. That is a spontaneous reaction. The spontaneous reaction stands for the chemical reaction that taking place on its own, whereas if you want to convert electrical energy into chemical energy, means whenever you need to have the chemical reaction, then it is a non-spontaneous reaction, right? So this we will discuss in the upcoming topics, in which you can have the cells, batteries, in which, as we know, that chemical energy, by the chemical reaction you can have the electrical current, whereas the electrochemical cell, in the 10th standard also you have studied the refining of the metals. So in that the electrical energy will transform into the chemical energy. Now the question is that if we are doing any work, anything, then there must be some intention behind, right? So what is the intention or what is the reason to study the electrochemistry in day-to-day life? So due to the various applications, the study of electrochemistry is very important. Say for example, one of the application, what we can say in the medical field, is the transmission messengers, right? The neurotransmitters working, the mind is getting the signals in the nervous system through the electrochemical process. So we can say it is a interdisciplinary study, interdisciplinary branch. So various uses are there. In the same way, in 10th standard you have studied about the refining of metal. In that, electrochemistry is also important. That electrochemistry is also important for the volumetric analysis. Like in 12th standard, you are having the practicals of the redox reactions. So in the redox reactions, the redox titrations you are performing for the volumetric analysis. So you can define the metals, you can do the volumetric analysis, and one of the most important use nowadays, that this technique can be used for the generation of electric current in eco-friendly way. As we know, the conventional energy method, that by using the thermal power plants, right? In thermal power plants, the water transform into the steam and turbines are running, right? So to have that energy, we are using the coal, which is not eco-friendly, doing the pollutions. So alternatively, what we can use is, we can use the fuel cells which generates the electric current in the eco-friendly way. That's why it is very important as a choice nowadays. Now first of all, let us start with the study of electrochemistry with one of its application, that is the study of Daniell cell. Study of Daniell cell. So Daniell cell is one of the cell which is electrochemical cell. It belongs to the electrochemical cell. So basically what is there in the electrochemical cell? In the electrochemical cell, the electrical energy obtained by chemical reaction. So by having the chemical reaction, you can generate the electric current, right? So let us discuss the Daniell cell now. So in the construction of Daniell cell, you are supposed to take two containers. In the two containers, the one container will comprise zinc sulfate aqueous solution, whereas another container will comprise copper sulfate solution in the aqueous form. Preferably you can have 1 molar concentration and you can have 1 molar concentration. Now in the zinc sulfate solution you can dip the zinc strip, that is zinc in the solid form, and in the copper sulfate solution you can dip the copper strip, that is copper solid, right, in the solid form. Now both the containers comprising the strips, they are connected with the ammeter to measure the current flow, to measure the flow of the current by the ammeter. And one of the most important thing we are supposed to add here is a salt bridge. The salt bridge will connect electrically both the containers to maintain the electrical neutrality in the container. How it will maintain the electrical neutrality, that I will explain in the later part. So in between you have inserted the salt bridge. Salt bridge is inserted and ammeter is used for the measurement of the current flow, right, for generation of the electricity. Now what will happen? Now both the containers are separated. Zinc is dipped in the zinc sulfate, which will act as anode terminal, and anode is negatively charged. Here the copper strip dipped in the copper sulfate solution, that will be act as cathode, and that will be positive. Now the question would arise in your mind that, sir, why zinc is negative, why copper is positive only? Can't copper act as anode and can't zinc act as cathode? Yes, the question is correct, but that you will study in the later part. Why particular metal will become anode and particular will become cathode in this case, right? So now let us consider first the case. What will happen in in this experimental setup? So the anode is there. In the anode you have dipped the zinc strip, and in the cathode you have dipped the copper strip. Now as soon as it will be connected through the wire and the salt bridge, when it will be inserted, then the electron flow will start. It will start generating the electrons. So electrons will flow from the zinc to the cathode, that is anode to the cathode copper, right? The flow of electron will be started. So how you can represent the flow, how you can represent the chemical reaction for this case? So we are writing the chemical reaction for the anode. On the anode terminal, the oxidation reaction always taking place. So during the oxidation, as we know that zinc solid will transform into the Zn2+ ions in the aqueous form by the loss of 2 electrons. So 2 electrons will lose during the chemical reaction. So here as you can see, the loss of electrons in 11th standard also you have studied, it is an oxidation half reaction. It is considered as a oxidation half reaction. Whereas for the case of the copper, it will be behaving as a cathode. On the cathode, reduction reaction will be there, and for the reduction reaction, the copper ions in the copper sulfate are available in the Cu2+ aqueous form, that will accept the electrons, 2 electrons from the zinc, generated from the zinc, and it will be transformed into the copper 0, that is copper solid, right? So this is a reduction half reaction. Now always you have to remember that on anode, dissolution will be taking place. Dissolution, that is, from the Zn solid, the zinc 2+ will be deposited, will be dissolved in the form of Zn2+ in the container. So this solution on the left hand side is going to become positive charge. Gradually it is going to become positive. On another hand, what will happen, that copper 2 plus from the aqueous form, they will be deposited on the surface of the copper solid strip, right? In the solid form it will be transforming, means here deposition will be there, the copper will be deposited, right? And that is how the electricity will be produced and the electric current will be generated. Now this is the flow of electron from anode to cathode, then the current will always flow in the opposite direction, means the flow of direction of the current will be in the opposite side, that is from the cathode to the anode, right? I hope you can understand what I mean to say, right? Now as a net redox reaction, you must be knowing that while I am writing the net redox reaction, from both the sides 2 electrons will get cancelled, and net redox reaction you can write it as zinc solid plus copper 2 plus aqueous gives Zn 2 plus aqueous plus Cu solid. So in short, what we have learned today in this lecture? In this lecture, we have just discussed about the case for the transformation of chemical energy into electrical energy by having the chemical reaction. Always, as I said, on the cathode terminal dissolution will be there, on the anode terminal dissolution will be there, whereas on the cathode terminal deposition will be there, right? Thank you.